So I want you to imagine walking onto a massive multi-million-dollar construction site.
Okay, picture painted.
Right, and you're the project manager. And your team just got this, like, revolutionary automated crane. It builds skyscrapers at literally 100 times the speed of a normal human crew.
Oh, wow.
Yeah, so you blink, and the steel frame is up. You go grab a coffee, come back, all the plumbing is routed. But here's the catch. This crane completely refuses to use blueprints.
Uh-oh.
Right? It leaves no paper trail. It doesn't log any of the materials it used. It doesn't tell you if the welds were actually inspected. And then at the end of the day, it just powers down.
So you just have this standing building and no idea if it's safe.
Exactly. You have absolutely no idea if it's going to just collapse when the wind blows. And, well, welcome to the deep dive. Because we are looking at that exact crisis today. Not in physical construction, obviously, but in software development.
Yeah, it's a terrifyingly accurate analogy, honestly.
Right. Our mission today is to unpack this stack of recent conceptual notes and documentation. These are from June 2026, written by a team, Luigi and Berta, regarding a system called Berta Seal.
Berta Seal, yeah.
And we're exploring this massive, profound shift in how we manage AI coding agents. Because they're doing real high-speed work now, but they're leaving this profound accountability vacuum in their wake.
Yeah, the central tension we really have to resolve here is that, we gave artificial intelligence the power to write production-level code at these blistering speeds, but we entirely neglected to give it the discipline to clean up after itself.
We really did. It's all speed, no safety net.
Exactly. And the Berta Seal documentation frames this around a concept they call the closure ritual, which is it's this habit human engineers have developed over decades to basically build trust. And it's something that default AI models fundamentally cannot do because of their underlying architecture.
I want to dig straight into the mechanics of that limitation, because the docs make this really fascinating distinction between the old era of AI, where it was just, an autocomplete toy suggesting the next line of code.
Yeah, the glorified spell check era.
Yeah, and the current reality where autonomous agents are spinning up tickets, they're creating branches, making actual architectural decisions. So the gap between work happened and work is accounted for is just widening so fast.
It is. And the evaporation of context is really the core technical hurdle there. Think about how a human developer operates, right? If I ask a senior engineer why they made a highly specific architectural choice, say, implementing a particular caching layer 6 months ago.
They usually kind of groan, but they remember.
Right. They possess a continuous narrative identity. They can look at the code base. They recall the constraints they were under. They remember, oh, yeah, the API rate limit edge cases we were fighting. And they can explain the rationale.
Because the human brain maintains a persistent state.
Mm-hmm.
Even if the memory's a bit foggy, that foundational context is anchored in their mind.
Exactly. But an AI agent operates on a completely stateless architecture. When we talk about context windows in large language models, we are talking about a rigid, hard mathematical boundary.
Right.
Once that window fills up with tokens or, once the session is cleared, the agent's entire reality is just annihilated.
Annihilated. That's a good word for it. It's just total immediate amnesia.
Total amnesia. The model processes the input, it generates the output, and it retains absolutely zero persistent memory of the reasoning framework that led to that output.
So a developer might collaborate with an agent for, 3 hours? Wrestling with some complex database migration.
Oh, easily. And the code gets written. But then the browser tab closes, and from the agent's perspective, that session never existed at all.
Which means the only proof that anything happened is just a merged pull request sitting in the repository, usually with some highly unhelpful one-line title like update components.
Or just refactored logic.
Yes, refactored logic, which tells the rest of the team absolutely nothing about the underlying design philosophy or, the 10,000 lines of code that were just restructured. It's exactly like our chaotic automated crane dumping a finished building on the lot and wiping its own hard drive.
And that brings us to what the human discipline of the last few decades actually achieved in software engineering. Over the years, frameworks like Agile and Kanban, they didn't just emerge to manage time, they emerged to manage trust.
I really like how the documentation phrases that. It's quite poetic about this human loop.
It is. We open a ticket when we start.
Yeah.
We note down the various approaches we tried. We attach the tests we ran. And we only move that card to the done column when we are personally willing to defend the outcome.
Personally willing to defend the outcome. That phrasing, it implies a real stake in the ground. It's an assertion of quality, of accountability.
Yes.
Because when an AI agent arbitrarily marks a task as complete, It has no skin in the game. It isn't going to be paged at 2 a.m. when the production server inevitably crashes.
And that dynamic is precisely why organizations are experiencing this massive trust deficit with AI-assisted development right now. The unease isn't rooted in the quality of the generated code.
Right, because modern models produce exceptionally high-quality code.
They do. The unease stems entirely from the breakdown of that rhythm of trust. So Berta Seal is engineered to force the AI to respect this human rhythm.
To make it act a bit more human in its process.
Exactly. It imposes a structure where the agent must provide a clear opening, a recorded middle, and a really honest ending.
Okay, so let's look at how Berta Seal technically enforces that clear opening. The workflow initiates with a surprisingly simple command line interface, or CLI command. It's just seal open.
Just seal open, yeah.
And instead of relying on a graphical user interface or some browser extension, this command runs directly in the terminal and reaches out via the Atlassian API to create a tangible Jira ticket on the team's shared board.
And that reliance on the CLI is a highly deliberate architectural choice. It makes the workflow universally compatible and, crucially, agent agnostic.
Meaning any agent can use it.
Right. Any AI coding agent that has permission to execute shell commands within the local repository, so whether that is Cursor, Claude Code, GitHub Copilot, Windsurf, any of them can trigger this workflow.
That's huge for adoption.
It really is.
Right.
The command authenticates, it formats a REST payload, navigates Atlassian's rate limits, generates the Jira ID, and then it injects that ID directly back into the agent's system prompt.
Okay, but I can hear the immediate objection from development teams right now, because the entire value proposition of AI was supposed to be like frictionless speed.
Oh, absolutely.
So forcing an AI to stop, execute a shell command, wait for an API handshake, and open a Jira ticket.
Yeah.
It feels like injecting bureaucratic red tape back into a process we just streamlined.
Yeah.
I mean, human developers already despise managing Jira tickets.
They do. Friction is almost always perceived as the enemy of speed. But the sources provide a really robust defense of this. They call it the marker of intent.
The marker of intent. Okay.
Because an intent to work cannot exist solely within a loose, ephemeral, conversational chat bubble between one developer and one AI model. If the work is not visible on the shared organizational board, it essentially does not exist to the rest of the engineering team.
And the danger of that silent divergence becomes exponential when you scale it up, right?
Exponential, yes.
Like, imagine a scenario where 3 different developers are driving 3 different agents in the exact same repository. Developer A tells their agent to optimize the read queries for the user database.
A standard task.
Right. But then developer B instructs their agent to restructure the indexing schemas for that exact same database. Because neither agent formally announced their intent to the broader system, both models begin heavily modifying the underlying data structures in parallel.
And 2 separate paths diverge silently in the dark. The developers remain completely unaware of the collision until they attempt to merge their respective branches.
And then boom.
Boom. At that point, they are hit with catastrophic merge conflicts, broken database migrations, and a code base that basically contains 2 entirely contradictory architectural philosophies.
Yikes. So the seal open command acts as like a localized locking mechanism.
That's exactly it. It forces a shared, visible opening gesture that alerts the entire organization to the work in flight.
It also establishes a really crucial psychological boundary for the human operator, because the source notes emphasize that executing seal open shifts the state of the session from exploration mode strictly into execution mode.
Which is an important distinction. Exploration is highly valuable. Asking an AI to generate a quick Rust mockup or brainstorm a new UI layout, that's all part of the creative process.
Right, you just play in the sandbox.
Exactly. But exploration should never be mistaken for delivery. The moment the seal open command executes, the developer and the agent are making a formal declaration that the sandbox phase is over.
The gloves are off.
Yeah. The work is now being tracked, measured, and it is bound for the production environment.
So the intent is crystallized. The ticket is open. The AI is officially on the record. But announcing the work is only the first step, because the reality of software development lives in the messy middle.
Oh, the messy middle.
Yeah, the partial fixes, the abandoned approaches, the endless cycle of testing and debugging. How does Berta Seal capture that chaos in a way that is actually useful to a human reviewer later?
So traditionally, human engineers capture this messiness by leaving comments, attaching logs, updating subtasks, and AI agents are perfectly capable of generating robust logs and test outputs.
They write great logs.
They do. The fundamental problem is placement. Agents typically just dump a massive block of raw text into the chat interface, claiming the tests pass.
Trust me, it works.
Right. And once the developer closes that chat window, the proof is just gone.
Yep.
So Berta Seal addresses this with its second core command, which is seal test -- run.
Let's dissect the mechanics of that command, seal test -- run. Under the hood, this executes whatever testing suite the project has predefined. So whether that's Jest, PyTest, or some custom bash script.
Whatever the team already uses.
Right, but instead of just printing the standard output to the developer's terminal, it intercepts that output and writes it directly back to the Jira ticket.
And it does not just paste a raw text dump. That's the key. The command actually parses the standard output and standard error streams, and it structurally converts them into Atlassian document format, or ADF.
Okay, so it creates a dedicated subtask on the original Jira ticket, populating it with these ADF tables and native log attachment.
Exactly.
But converting the logs natively into ADF seems like a really massive technical detail.
Yeah.
Why is that specific format so critical? Like, why not just use standard markdown or plain text?
Because plain text is functionally invisible to a database.
Oh, interesting.
Yeah, by utilizing ADF, the test parameters, the execution timestamps, the specific failure states, they're all converted into structured, abstract syntax tree nodes that Jira's internal backend can actually understand.
So it's not just a block of text, it's data.
Exactly. This integration means the data becomes natively searchable via Jira query language. So a human engineer can run a query 6 months later to find, every AI-generated test that failed a specific latency threshold.
Wow. And the documentation refers to this as legible verification.
Yes, legible verification.
So we are moving away from the vibe of quality assurance. The classic developer claim of, well, it compiled fine on my local machine, and we're demanding a verifiable structural trace. It's like a mechanic.
Oh, so?
Well, is the difference between a mechanic handing you your keys and saying, engine sounds fine to me, versus handing you the actual computerized diagnostic printout proving that all the cylinders are firing correctly?
That is a perfect analogy, because legible verification is really the cornerstone of accountability. When a critical service goes down in the production environment, the incident response team doesn't have time to guess what an AI agent might have done 3 weeks ago.
They need answers immediately.
Exactly. The difference between, I think the agent ran the security checks, and here is the exact ADF formatted test run, here's the exact state of the Git tree when it executed, and here is the native log output. That is the difference between an agonizing, multi-hour retroactive hunt and a targeted 5-minute remediation.
It fundamentally removes the archaeology from debugging.
Yes.
The evidence is sitting right there in Jira, formatted exactly as a meticulous human engineer would have presented it. We basically forced the chaotic intern to show their math.
No, their math, exactly. So we have the open ticket and we have the verified test logs, which leads us to the most critical and honestly, arguably the most philosophical component of the entire Berta Seal framework.
Which is the enforcement of the closure loop.
Right. The documentation takes a definitive stance on the concept of completion, stating that done is not a technical state, but a human commitment.
A commitment implies taking responsibility. An automated script returning a zero-exit code just means the code compiled. It doesn't mean the code actually serves the business logic or meets the agreed-upon organizational constraints.
Right.
And AI models, by their very nature, lack the broader context to make a human-grade commitment. They can suggest that a task is finished, but they should never have the authority to silently declare victory.
And Berta Seal enforces this boundary through its third command, seal done.
Seal done.
Yes, this operates as a strict API-level blockade against what the industry calls empty ticket churn.
Empty ticket churn. That's the dangerous habit of just dragging a ticket across the Kanban board to the done column without providing any verifiable proof of the work.
Exactly. We've all done it, but it's terrible practice.
So how does that blockade actually function at the API level?
So when the agent attempts to execute seal done, the CLI sends a pre-flight request to the Atlassian backend. It specifically queries the Jira ticket to verify the existence of that ADF formatted test subtask that should have been created by seal test -- run.
It's checking its own homework.
Essentially, yes. It checks the state of that subtask. If the subtask does not exist, or if the logs indicate a test failure, the CLI intercepts the transition request and physically prevents the Atlassian API from moving the ticket state.
Wow.
The ticket simply remains open.
That is a very rigid constraint. But Any senior engineer looking at this workflow is going to immediately spot the inherent flaw here.
Oh, for sure.
A test suite can pass with flying colors, the logs can be perfectly formatted in ADF, and the code itself can still be an absolute architectural disaster.
Yep.
It could introduce a massive security vulnerability that the specific test just wasn't designed to catch. So doesn't this strict programmatic blockade create a dangerous false sense of security?
Yeah.
Like teams might see a closed ticket and just assume the AI did a perfect job?
And the authors of the Berta Seal documentation actually anticipate that exact critique. They explicitly state that the system is not a guarantee of correctness.
Okay, good.
Yeah, passing tests do not equate to flawless architecture. Berta Seal is not an automated judgment engine designed to replace human code review.
Then what is the ultimate value of the blockade if the code still requires human scrutiny anyway?
The value is defined by a really specific phrase in the text. It removes the excuse that nobody wrote down what was checked. The blockade forces the AI to bundle its delivery with context. So when the human reviewer eventually sits down to evaluate the pull request, they aren't staring at a black box. They possess the complete, immutable record of the AI's intent, the specific tests it chose to run, and the structural logs of the results.
So it basically holds the AI to the exact same standard as a junior developer. Because if a junior engineer submitted a massive pull request without documenting their reasoning or attaching their test results, a senior developer would reject it outright. You still review the junior developer's code, but you demand the documentation as a prerequisite for that review.
And that analogy is utilized directly in the source material. Treating the agent's output with the same rigorous requirements we apply to human contributors is a deeply practical stance. It ensures that the chain of custody regarding architectural judgment is just never broken.
Okay, so the accountability loop inside Jira is solid. The receipts are on the board. But this actually exposes an entirely different limitation.
Which is?
Jira is an exceptional tracking tool, but it is fundamentally terrible at narrative memory. Like, if a developer needs to understand the nuanced conversational reasoning behind a database schema change that was made a month ago, Jira's structured tables are incredibly unhelpful.
Very true. Jira answers the what and the when. It tells you what is currently in flight and what the status was on Tuesday. But it completely fails to answer the why.
The why is always the hardest part to track down.
Right. And this is where the documentation introduces an optional, yet highly critical companion system called Orchestra.
Orchestra. If Jira is the itemized receipt showing the transaction, Orchestra is kind of like the detailed diary entry explaining the emotional and logical reasoning behind the purchase.
I love that, yes. Orchestra functions as a shared, searchable memory layer that basically sits above the fragmented ecosystem of individual AI tools. Berta Seal essentially creates what they call a dual memory system.
Okay, how does that trigger?
When a developer successfully executes the final seal done command, assuming the API blockade is cleared and the Jira ticket closes, the system simultaneously generates what the notes call a delivery card.
And this delivery card is written directly into Orchestra's vector database.
Correct. It contains the rich narrative context of the entire session, the story of the ticket, the abandoned approaches, the back and forth dialogue regarding the architectural trade-offs. And because Orchestra operates independently of the IDEs, it bridges the gap between competing tools.
Which solves a massive pain point in the current market, honestly, because the AI tooling landscape in 2026 is heavily fragmented.
Oh, it's a mess.
A developer might use Cursor for complex refactoring on Monday, switch to Claude Code for front-end generation on Tuesday, and then rely on GitHub Copilot for quick inline suggestions on Wednesday. None of those tools share a centralized memory state.
They exist in completely isolated silos. So by writing the delivery card to Orchestra, a developer can query that unified memory space weeks later. They can ask, what were the security trade-offs we discussed when shipping the database migration last month?
And they get the answer.
They will receive the full narrative context entirely regardless of which specific AI agent originally generated the code.
That is incredibly powerful. The documentation points out that this pairing comprehensively solves the two distinct forms of AI amnesia. First, the forgetting in the tracker, where work is executed but never formally logged in Jira, which Berta Seal solves.
Right.
And second, the forgetting in the chat, where the nuanced reasoning is destroyed the moment the context window is cleared, which Orchestra solves.
Together, they synthesize a complete, immutable organizational memory. We're basically scaling up the small habit of the closure ritual to match the blistering speed of AI delegation.
Because if an engineering department attempts to scale AI velocity without simultaneously scaling these habits of closure and memory,
The entire organization will eventually drown in a sea of untrackable, orphaned code.
yeah, nobody wants that.
Yeah.
So the philosophy is airtight and the architecture is really elegant, but the reality of enterprise software relies entirely on the pragmatics of implementation. How does a massive engineering organization, potentially managing hundreds of distinct repositories and client projects, actually roll this out?
Well, the configuration is remarkably streamlined. It revolves around a single centralized file called programs.json.
Wait, just one JSON file?
Just one. This file acts as the universal mapping layer, connecting local Git repositories to their corresponding Atlassian project IDs.
But managing hundreds of projects through a single JSON file seems incredibly daunting. How does it handle the varying security and operational requirements of different teams? I mean, not every project needs the same level of lockdown.
Right, and the programs.json file allows for highly granular per-project policy enforcement. So, for example, an organization's core production repository might be configured with a strict always create policy.
Okay.
In that environment, the AI agent is physically blocked from executing any code modifications until a Jira ticket is formally opened and linked.
But you wouldn't want that level of friction everywhere. Like if a developer is using an agent to write a quick Python script in a temporary sandbox folder, you don't want the Atlassian backend flooded with garbage tickets.
Exactly. For that specific sandbox path, the JSON configuration can enforce a never create policy or an always ask the human first policy. The organization maintains absolute surgical control over exactly where the friction of the closure ritual is applied.
Okay, that makes sense. To assist teams in navigating these JSON configurations and API mappings, the higher-tier subscription plans include access to a specialized project assistant bot.
Yes, the bot.
But the documentation is remarkably specific about the constraints placed on this bot. It is not just another conversational agent, is it?
No, it's very restricted. The project assistant is a highly scoped tool utilizing retrieval augmented generation, or RAG, and it's strictly limited to the organization's specific Berta Seal configuration and Atlassian setup documentation. Crucially, it operates firmly out of bounds regarding actual code-based execution.
The notes emphasize that it refuses to ask for API tokens, refuses to engage in general code inquiries, and explicitly will not write or refactor code.
Right.
It is essentially a dedicated, automated IT support specialist whose sole directive is ensuring the Berta Seal integration remains healthy.
It guides developers through the Jira Bootstrap process. It runs diagnostic health checks on the CLI workflow. It is a support mechanism, not a development tool, which significantly reduces the security surface area of the implementation.
And this level of enterprise control brings us to the business model, which contains a pretty massive paradigm shift for DevOps tooling. The source material outlines a highly time-sensitive launch window closing on August 1st, 2026.
The pricing architecture itself is the major takeaway here, honestly. Berta Seal fundamentally rejects the standard industry practice of charging based on the number of connected projects or repositories.
So how do they charge?
Instead, they charge strictly per agent seat.
I really want to focus on why that distinction is so revolutionary for the buyer. Because in my experience, evaluating enterprise SaaS tools, charging per project acts as a massive tax on success, particularly for development agencies.
Oh, it's a huge burden.
If an agency scales up and takes on 50 new client repositories, their tooling costs skyrocket exponentially, even if they only have a core team of 5 developers.
It creates a perverse incentive where teams start consolidating work into massive, unwieldy repositories simply to avoid triggering higher billing tiers. But Berta Seal flips that economic model. You purchase a seat license for the developer agent pair. Under that single license, the developer can map an unlimited number of Atlassian projects through their programs.json file without incurring a single cent of additional cost.
That is a big deal. And the launch pricing available before the August deadline is quite aggressive. The solo plan, which provides 1 seat with unlimited Jira mappings and the full API blockade workflow, is listed at $79 per year during the launch phase.
But on August 1st, that standard list price jumps nearly double to $149 per year.
Right. And then the team plan, which provisions 5 seats, sits at $49 per month during the launch. This tier introduces the project assistant bot, shared organizational templates, and priority onboarding.
And post-launch, that transitions to $79 per month.
Then for massive organizations requiring unlimited seats, the enterprise plan is $149 per month at launch, increasing to $249 per month standard. This one includes custom agent prompt packs, single sign-on integration, and bespoke invoicing.
But the most strategic offering by far is the Orchestra plus Seal bundle.
Right, combining both systems.
Yeah. The bundle provides the complete dual memory system, both the strict Jira accountability and the cross-tool vector memory space. The launch price is a flat $149, which then violently jumps to $279 after the deadline.
And the critical detail in the documentation is that securing any of these tiers before July 31st, 2026 locks in the launch pricing in perpetuity.
Forever.
Yeah, it's a permanent discount for early adopters. But, the FAQ section tackles a broader question about the fundamental value proposition here. Why invest heavily in a premium CLI workflow when the market is already flooded with cheap, open-source Jira plugins?
Well, the authors argue that Berta Seal is not a simple ticket widget. It is a foundational infrastructure play. They refer to it as agent DevOps.
Agent DevOps.
Buyers are not paying for a macro button. They are paying for immutable evidence trails, programmatic API blockades, and really extensive future-proofing.
And that future-proofing aspect is vital given the sheer velocity of the AI market right now. The documentation guarantees that as new, disruptive AI coding agents and IDEs inevitably launch over the coming years, Berta Seal will provide integration updates as free upgrades for existing subscribers.
There is no per-tool fee. If an entirely new paradigm of autonomous coding drops next quarter, the CLI workflow will adapt to support it. The business model is a calculated bet that the fundamental need for organizational accountability will outlast the lifespan of any specific AI model.
The technology will keep changing. The need to close what we open will not. That line from the notes perfectly summarizes the whole philosophy for me.
It's a great line.
So we started this exploration looking at a chaotic, hyper-fast AI intern generating brilliant code while just incinerating its own blueprints. We examined the architectural reality of context amnesia and the resulting erosion of the closure ritual.
And we analyzed how the CLI workflow rebuilds that trust, the seal open command enforcing intent and preventing catastrophic parallel divergence, the seal test -- run command converting standard outputs into structured Atlassian document format for legible, searchable verification.
Then the seal done command utilizing Atlassian's API to physically block empty ticket churn, demanding real human-grade commitment. Plus, the integration of Orchestra to conquer the narrative memory gap across fragmented IDEs.
And of course, the strategic economics of seat-based pricing ahead of the August 2026 infrastructure deadline.
It really is a profound, fully realized architecture for dragging mature engineering discipline into this new era of autonomous delegation.
It truly is.
But, staring at this perfectly engineered framework leaves me with a lingering, somewhat uncomfortable thought.
Uh-oh. Salah.
Well, we have spent this entire session detailing how to force artificial intelligence to operate with the absolute highest standard of accountability. We are demanding structured ADF logs, immutable programmatic verifications, and perfect cross-tool narrative memory continuity.
We have constructed an uncompromising standard for the machines.
Exactly. But if Berta Seal successfully normalizes this immutable closure ritual, if we eventually achieve flawless, instantly searchable evidence and logic trails for every single action an AI takes, how long will it be until human developers are expected to meet the exact same rigorous, hyper-documented standard?
Oh, wow.
Right. Will the flawless discipline of the automated agent eventually expose the inherent sloppiness of our own human workflows? We built the tool to fix the chaotic intern, but we might eventually look in the mirror and realize the chaotic intern was us all along.
That is a terrifyingly good point.
Just something to consider the next time you forcefully drag a Jira ticket to done without leaving a single comment. Thanks for joining us on this deep dive.